Assalamualaikum my students, I'll sit here. As you know that we have already discussed this differential equations and we have also discussed how to find out a differential equation from given function. Now today we have a topic that is solution of differential equation. In our previous lecture we had a function f of x there and we were differentiating this function in order to find out the differential equation, or in order to make the differential equation from this function. We were making that differential equation by differentiating this y is equal to f of x with respect to dependent variable x, and then we were removing the constant, the arbitrary constant. Now if we have given differential equation, just as the inverse of our previous lecture, today if we have given differential equation, for example d square y divided by dx square plus y equal to 0. If this is our differential equation and we have to find out its solution, the solution of the differential equation is actually the function y is equal to f of x. Is actually the function y is equal to f of x, such that the derivatives that this function and the derivatives of this function satisfy this equation. Are you getting my point, beta? I am telling you, if we have a differential equation that is, I am taking like this, a simple example, and if I have y is equal to f of x such that this y is equal to f of x and the derivatives of this y is equal to f of x satisfy this equation, then we say this y is equal to f of x, the solution of this differential equation, or we say it the integral of this differential equation. It is very easy. So I am telling you here a solution, or we also say it integral of a differential equation like this, is a relation between the variable. Is the relation between the variable. That means is the function actually. This y and f of x. This is the relation between y and x. So here, not involving the differential quotient, and that integral, that solution does not involve any differential quotient. You check here. Here in this function there is no differential quotient. Such that the relation and the derivative, such that this relation and the derivatives of this relation satisfies the given equation, satisfies the equation. So it is easy now. If we have given the function, if we have given some differential equation, we have to check out some function that will satisfy that function, and the derivatives of that function will satisfy the given differential equation. Then we say that function or that relation of dependent and independent variable is called the solution of the differential equation. Now you write down this definition. So we will take first some examples that will make us understand it very clearly. Now I will take a simple example. You also write this example. Check whether y is equal to a cos x plus b sin x is a solution of d square y divided by dx plus y equals to 0. This is our given equation and we have to check whether this function is the solution of this differential equation or not. So how we can say this is solution of this equation? We can say it only the solution of this equation if it satisfies this, if this function or if this relation and the derivatives of this relation will satisfy the differential equation. So we will solve it. You write solution. We have y is equal to a cos x plus b sine x. We have to check this is the solution of this or not. So you take it as first. Now we will differentiate this function because we have to check this function is the solution of this differential equation, and we have to find out the derivatives, and after that we have to check that we have to substitute the derivatives in this function and check whether this is the solution of the equation or not. Now you check here. Sorry, I will first. We have to check whether this is the solution of this or not. So for that we have to find out whether the derivative and this function will satisfy it or not. And we need here the derivative of second order. So we will differentiate it two times. So first when we will differentiate it with respect to x, we will get dy by dx equals to, you check here, this is arbitrary constant, this is constant, and it will be as factor, and the derivative of this cos x is minus sine x. So minus I will write here, and then this sine plus the derivative of this b sine x. What is that? B cos, because the derivative of sine x is cos x. This now we will differentiate it again because we need here d square y divided by dx. So we will differentiate again with respect to x. So it will be d square divided by dx equals to, you check here, it is minus a. The derivative of sine x, what is that? Cos x, plus this is b, the derivative of cos x is minus sine x. So plus minus will become minus b sine x. Now this is our second equation, and we take this third equation. Now d square y divided with dx square plus y equals to, we will check whether this is equal to 0 or not, but we will substitute this value. So we have d square y divided dx, we have that minus a cos x minus b sine x. Then we have plus y. What is y? A cos x plus b sine x plus a cos plus b sine x. Now you check here, this is minus a cos x, this is plus cos a x. So this one and this one will get cancelled. This is minus b sine x and this is plus b sine x. So this will get cancelled, and we are getting d square y divided by dx square plus y is equal to 0. That means this function, this y is equal to this relation, and derivatives of this relation are satisfying our differential equation. So hence this is the solution of this equation. So you write down, hence y is equal to a cos x plus b sine x is the solution of the required given equation. So now we will go for another example. And that example you take like this. Show that yes, this one, xy equal to sine x is a solution of d square y divided by dx square plus 2 divided by x dy by dx, and then plus y equals to 0. So we have to check whether this xy is equal to sine x is the solution of this equation or no. So we will solve it. We have xy equal to sine x. So now we will differentiate this. So with respect to x, because we need second order derivative, and we have to check whether this relation and the derivatives of this relation will they satisfy the given differential equation or not? So we will differentiate it with respect to x, so it will x product rule here, and then differentiation of y, that is dy by dx plus this y, and the derivative of x, that is 1, equal to sine, or derivative of the sine x, that is cos of x. Now we will differentiate it again with respect to x, so we will get here x dy by dx, that will be d square y divided by dx square, and then plus dy by, and then the derivative of this x, that is 1, plus the derivative of the dy y is dy by equals to cos x. What is that? Derivative of cos x, that is minus sine. So here, which implies, you check here, we have xy equals to sine x sine x. So can I write instead of this sine x y? So here you check, this is x d square divided by dx plus dy by dx plus this is dy by dx, that will be 2i dy by dx, and then equals to minus sine x. What is that equal to? X cos xy, that is minus x y. Now we will give this x divided throughout, so here it will be d square y divided by dx plus 2 divided by x dy by dx. Why? When we will divide this x throughout, so x and x will get cancelled. Here it will be 2 divided by x is equal to, this x will get cancelled, minus y divided by minus y. So this is equal to d square y divided by dx square plus 2 divided by x dy by dx, and this I will transfer to the left hand side, left side, so it will be plus y equals to 0. So we have a function that was xy equals sin x, and we differentiated this function 2 times, and we got the differential equation that is equal to this given differential equation. So that means this xy satisfies the differential equation, xy and its derivative. So that means this xy equals to sin x is the solution of the required solution. So hence you write here, hence xy equal to sin x is the solution of the given equation. So these are the 2 examples that will help you to understand it properly. So now we will go for another definition. If we have a differential equation d square, some differential equation I will take as d square y, or I will take general differential equation of n order. We have a differential equation dm y by dx n plus so on equal to something p. This is our differential equation of order n, and if we get the solution of this differential equation in such a way, the solution, I will take this as solution. This solution has an arbitrary constant present. If we have a differential equation equals to this, and if the differential equation has solution y equal to f of x, but if the y is equal to f of x has an arbitrary constant. How many constant? An arbitrary constant. At that time, we say this y is general solution of dny divided by dx. Are you getting me? I am telling you, if we have a differential equation of order n, then if the solution of that differential equation is such that the arbitrary constant present in that solution, in that relation, are equals to n, then we say this is the general solution. For example, y equals to a cos x, as we have proved it, this y is equal to ax plus b sin x. We have proved it that it is the solution of this d square y divided by dx square plus y equals to 0. We already proved it. So here, this solution of this equation, of the differential equation, this solution has how many arbitrary constants? 2, a and b. So we call this solution the general solution of this differential equation. Now, if we have a solution y is equal to a cos x, if this is our solution to this differential equation, what? If y is equal to a cos x is the solution of this differential equation. But we have here only one arbitrary constant, but the order is here 2. We can't say that this is the general solution of this differential equation. For the general solution, the order and the arbitrary constants, they must be equal. So I hope you have got it. Now, so how many arbitrary constants are present in the general solution? So number of arbitrary constants is actually the number of arbitrary constants, but in general solution is equal to the order of the differential equation. Now we will go for another definition, that is particular solution. Particular solution. Particular solution, if we have a solution y is equal to f of x, and this is solution to some differential equation d and y divided by dx and plus so on equals to p. If this is the solution of the differential equation, but this solution is such that it has no arbitrary constant. It has no arbitrary constant. First we discussed general solution. In that general solution we discussed that the solution must have arbitrary constant, and the number of arbitrary constants should be equal to the order of the differential equation. But here I am telling you, if we have a relation y is equal to x power x, and this relation is solution of this differential equation, but this relation does not contain any arbitrary constant, then we say this is the particular solution of this equation. Are you getting me? I am telling you that if this is our equation and this is our relation, and this relation satisfies the differential equation and is the solution of the differential equation, but this relation has no arbitrary constant, then we say this is the particular solution of the differential equation. So it is NFR. So you take as this, you take this example. If we have differential equation d square y divided by dx square plus y equals to 0. If this is our equation, and if y is equal to is some relation, we will say y is equal to this thing is given 2 cos x plus 3 sin x. Here in this relation there is no arbitrary constant, but we will now check whether this is the solution of this equation or not. If this will be the solution of this equation, then we say that this is particular solution, because this relation has no arbitrary constant. So you check here, it is dy by dx will be equal to 2 minus 2 sin x plus 3 cos x, and then d square y divided by dx square, it will be equal to minus 2 cos x minus 3 sin x. I will make this minus as factor, so it will be minus 2 cos x plus 3 sin, but this minus 2 cos x plus 3 sin x, 2 cos x plus 3 sin x, that is equal to y. So y, so I will now transpose this y to left hand side, so it will be plus y equals to 0. Here it was minus y, so it will be here. So we had this thing, this relation, and we got from this relation the differential equation d square y. So this is the solution of this differential, but this solution is free from arbitrary constants. That means that this is the particular solution of this differential equation. Similarly, you can prove another, this y equals to 3 sin x. You can also prove that this is the solution of differential equation. So now you write down the definitions now to both these two, general and particular solution. You write down first. General solution. A solution which contains as many arbitrary constants. A solution which contains as many arbitrary constants as the order differential equation. Then the solution is called general solution of differential equation. So you take example, y equals to a cos x, b sin x is general solution of d square y divided by dx, but y is equal to a cos is not general solution. So this is our general solution, this is our definition for general solution. Now you write down the definition for particular. Particular solution. A solution which is free from arbitrary constants is called particular solution of differential equation. For example, y equals to 2 cos x plus 3 sin x is particular of d square y divided by dx square plus y equals to 0. So this is enough for today. Inshallah, tomorrow we are going to solve some examples. We are going to find out the particular as well as the general solution for some differential equation. Or we will also tomorrow discuss some methods that will help us to find out the solution of differential equation very easily. This was as inspection method. We were taking some function equal to y equals to something, and then we were checking whether the function is the solution of the differential equation or not. This is actually the inspection method. But tomorrow, inshallah, we will go for the methods of finding the solution of differential equation. And there are so many methods. First one we will go discuss there, that is variable separable method. So have a good time ahead.